recording now. Thank y'all for reminding me to record. So the compound interest formula, please underline that. And you're going to know to use this formula because the words compound interest will be used in the problem. A represents the amount of money in your account at the end of the time period. P is the principal, R is the annual interest rate, T is the time in years. So the P and the R and the T all mean the same thing in compound interest as they did in simple interest. Okay? The balance is the sum of the principal and the interest. So what they're doing here is they're introducing a new formula for compound interest. So if we went back to that first chart that I put up there, was it Ben who had $500? Was it Ben? Okay, Ben was not getting compound interest because he put in $500 and then he only made $20 each year. Compound interest is where you make interest on your interest. You actually get more money if the fund or the account that you're using is compounded instead of just having simple interest, because at year one where he had $520, compound interest will take the interest on $520 and then add it to that. And then the next year was $540. Well, they would take the interest on $540, which is going to be more than $500, the interest on $500, and then add it to that. So you're actually going to get more interest if your account is figured on compound interest. All right, it says compute compound interest using the simple interest formula. Simon deposits $400 in an account that pays 3% interest compounded annually. What is the balance of Simon's account at the end of 2 years? So what they're asking us to do here is they're telling us it's compounded, but it's telling us to figure this using the simple interest formula. So what is P in this problem? Let's kind of break it down. And what number represents the P value in this problem? 400. Okay. What number represents your R?
3%.
And what would that be once you take the percent sign off? 0.03. Time would be 2 years. Okay. Because it says compounded. Okay. I'm going to go back and I'm not going to circle simple interest. Because it says compounded, then you're going to choose this new formula. A is equal to P, parentheses, 1 plus R, close parentheses, to the T. That's the right formula, right? Okay? Because it says compounded, because the interest is compounded, we're going to change our formula here. Then we've got to make sure we can use our calculator. All right, so P is 400. The 1 is in the formula. That number 1 is in the formula for compound interest. Plus our rate as a decimal, close parentheses, and then our time is actually an exponent here. So we have an exponent of 2. Now what I like to do before I punch, you can actually put all of this, plug every bit of it into your calculator if you would like to. Okay? Let's just try to do it straight into our scientific calculator. So we would do 400. Then you would do the left parentheses. 400, left parentheses, and you're going to make your calculator look just like the work that we've set up. Then you would do 1 plus 0.03, close parentheses, and then you can do your exponent button, or you have an x squared button because we square a lot of things. You could do either one. You could do that upside down V and then the 2, or you could hit your square button. It's the x squared button. It's below the upside down V. Hit enter, and that gives us $424.36, and we would put our money sign on that. Okay? And what we need to do right now is I just want to walk around very, very, very quickly and make sure that you can get this number in your calculator. That you understand how to punch it in your calculator, how to plug it into your calculator.
Whatever.
If you're not getting 424.36, then we need to figure out why.
Continually. 100.
That's the square, after you do the parentheses.
Cool.
Okay. You can do that one for, if you're just gonna square something. So, 400.
Yeah, I got it.
0.00 plus parentheses squared. Here's Tucky falling apart. Now, one thing that you might be able to do is let's do this. 1 plus 0.03 plus parentheses squared. Times, let's see, go back and trig yours and get this one. See what I did? I did the 1 plus 0.03 in parentheses and I squared it and then I multiplied it.
About 400. Okay.
I did the parentheses first. You can experiment with both those.
Okay.
Okay? Alright, so what this formula does is it's a balance formula. Okay? It's a balance, but the interest is figured different here because it's compounded. You're actually going to make more money in this account than you would a simple interest problem. Alright? That example 1 says find the balance of the account after 2 years using the simple interest method. So if we have $600, we have an annual rate of 4%, and we have a time of 3 years. Okay? I'll tell you what we're going to do on this one. It's 5-2. Yeah, let me think about this for just a minute. We might want to. Alright, so what they're trying to get you to do here is they're trying to show you the difference between simple and compound. So this says simple, okay? So if we were going to do the balance at the end of the first year, we're going to use our simple interest formula here. So that's going to be A equals P plus what? PRT. Alright, because it didn't say anything about compounded interest. Alright, so then you're going to pick up your calculator and you're going to do 600 plus 600 times 0.04 times 3.
600 plus.
I'm going to go right here. So you're going to do A is equal to 600 plus 600 times 0.04. Not times 3, my bad, because this says the what?
First year.
First year, so it'd be times 1.
624.
624, that's what I got. Okay, so that's after the first year, $624. Alright, then it says use the simple interest formula again and calculate how much money you would have after the second year. So then that's going to be A equals 600 plus 600 times 0.04 times 2.
Oh, okay.
Alright, you don't have to keep writing that, but just use your calculator there and tell me what you're going to get using the simple interest formula for 2 years.
648.
Point. This is money. Y'all just get 648 even?
Yes, ma'am.
Okay, why am I getting 96 cents? Balance at the
600
end
plus 600.
of the first year. Y'all just got 648 period? Okay. Alright. Balance, oh, I know. Balance at the end of the second year. Balance at the end of the third year. I don't know. Y'all do 3. So now change that 2 to a 3 and tell me what your calculator says. 6 what?
672.
672 even?
Yes, ma'am.
Okay. All right, the next example I think is going to tell us to do the same thing. Anybody still copying?
Amen.
All right, it says principal is 850, the annual rate is 2.4, the time is 4 years. We're not going to do this one for the sake of time, okay? So y'all can just cross this one out. It's worked just like example 1. If I pick this one on a notebook quiz, y'all let me know we didn't do that one. All right, let's go to the next one. All right, computing compound interest using the compound interest formula. Jackie deposits $325 in an account that pays 4.1% interest compounded annually. How much money will Jackie have in her account after 3 years? So I'm wanting you to see the difference between the two types of problems. Here it specifically says that the interest is compounded. So you're going to choose a different formula. And that formula is A equals P, parentheses, 1 plus R, close parentheses, to the T power.
Alright, that's the pounds.
Yeah. There's not two compounded interest formulas. Compounded interest is always finding the balance. Okay? Simple interest, you have a simple interest formula where you're just finding the interest. It's I equals PRT. And then you have a simple interest formula that's finding the balance. P plus PRT. The compounded interest is always finding the balance. There's not two formulas. Okay? As soon as it says compounded, there's only one formula that you're going to choose. All right, we just got to make sure that we can plug this in correctly. So we have 325, parentheses, 1 plus 0.041, close parentheses, to the 3. And again, if they give you time in months, you'll have to change your months to
Years.
years. All right? Then I want you to be able to plug that straight into your calculator. Round if you have to the hundredths place. What do we know our answer's got to be more than? It's got to be more than 325 because we're making money off of that. Okay? If you got 1,271, would that make sense? It's kind of high, isn't it? Okay.
It is
What are y'all getting there?
366.6
300.
or $3. Yeah, 64.
Okay.
Yeah, calculator.
All right. So two people have just agreed on $366.64.
Cents.
Okay? Does anybody having trouble using your calculator? All right.
Mom, what did my mother calculators? I wondered with you.
I think what you're going to have to do here is I think we're going to have to do that parentheses part.
Sometimes you have to press the second and press parentheses.
I got 366 and 63 cents, 164.
Okay. So you're going to have to do the same thing here. You're going to have to start with your parentheses. So 1 plus 0.041, close the parentheses. This is your power key. So you have to hit that, and then you'll do your 3, and you do equal. Then you multiply by 3 times. You just got a different order.
Okay, I'm just gonna go through the rules. That's too much.
Okay. All right. And you know we have those to loan out for the semester. If you want to get a little slip of paper, you just sign it, bring it back to me. I'll hand you a calculator for the semester if you want to borrow one. All right, you try. You try number 3 and number 4. Find the amount in an account after 2 years using compound interest. Using compound interest. You try number 3 and number 4. All right, somebody want to share your answer for example 3? Togi?
Is it 319.07?
$319.07. 319.07. All right, how about example 4? Anybody want to share their answer for example 4? Gracie?
1,407.88 cents.
And 88 cents. Okay. Is anybody having trouble plugging these numbers into your calculator? Now here's the reason. I know some of you might be going, why do I have to write this down if I'm going to plug it straight into my calculator? I totally agree with you. We can all get these answers without plugging them in our calculator, but because we're human beings, we make mistakes. And I do give you partial credit. So it's always a good idea to write down at least one little step. If you're going to do every bit of it in your calculator, that's awesome. But if you will just put the numbers into the formula for me, and then if you make a mistake entering it into your calculator, I will still go back and give you partial credit. So I want to be able to kind of see what you're thinking. And if you do all your work in your head, okay, sometimes it's okay. Like those problems that we're doing with Kahoots, I kind of wanted y'all to do those without any work. Okay, but if all possible, at least write down one little step of work, and then if you make a mistake going from the problem to the answer, we can see kind of what maybe you made a mistake with. All right, so here's the deal.